Hello and welcome to my Pre-Algebra review series. This video covers Chapter 2, Section 3, titled Simplifying Variable Expressions. By the end of this section, you'll have explored variable expressions, be able to identify the parts of a variable expression, and use the new knowledge while working to simplify variable expressions. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It will more than likely help them, and certainly it will help this channel to be seen by more students. If you'd like me to cover any of these topics in greater detail, please leave a comment in the comment section below. I read them and do my best to address each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you. Okay, definitions. Let's start by talking a few different items here that we're going to be discussing in this section. A term is a number or a product of a number and a variable. A constant. A constant is a term that has no variables. Like terms have identical variables. Coefficients. A coefficient is a number that multiplies a variable. Simplify a variable expression. You simplify a variable expression by replacing it with an equivalent expression that has as few terms as possible. Deductive reasoning. Deductive reasoning is the process of reasoning logically from given facts to a conclusion, as you use properties, rules, and definitions to justify the steps in the problem. You are using deductive reasoning. Objective 1, identifying parts of a variable expression. So when you have a variable expression that includes subtraction, you can rewrite the expression using only addition. This will help you to find the coefficients and the constants. Let's look at this example here. We have 5x, and then we have a negative or a minus 3y plus z and minus 2. So these are the negatives they're talking about up here when they talk about when we have subtraction in the problem, we can rewrite it as addition only. Well, how are we going to rewrite it? We're going to say, now 5x, instead of negative 3y, we're going to say plus the quantity, negative 3y plus z, we already have a plus z, and minus 2, we're going to write it as plus the quantity of negative 2. So now we've got written all these negatives, or these two negatives, as positives, and we brought the negative sign in with the variable, or the coefficient of the variable, and the constant itself. So we've rewritten it. Okay, so we've now changed out the negative sign, the minus signs, for positive plus signs. So then we end up with 5x, as you see here, plus a negative 3y, plus 1z, because now the z, there's a 1 right here in front of the z. It's understood to be 1z. So here we have 1z plus the quantity negative 2. Rewriting the expression using addition shows that the coefficients are 5, negative 3, and 1. Okay, those are the coefficients. And the constant is negative 2. And what did say minus 2, you could have thought, oh, there's a positive 2, I'm just subtracting it. Well, it's really a negative, it's plus a negative 2. And that's what they've shown here. Notice that the sign between the terms in the original expression determines whether or not the coefficient is a constant, is positive or negative. Okay? So example 1, identifying parts of an expression. Name the coefficients and the like terms and the constants in this following expression here. So we have 3m, that's a positive 3m. We have this negative 2n, or minus 2n, plus n minus 4. Well, the coefficients are the number that sit here in front of the variable term. Okay? And in this case, if you rewrite it, we have 3m, and we have plus, that's why they showed this last time, plus the quantity of negative 2n, okay, plus n, minus, which is plus the quantity of negative 4. And now you can see that the -2 and -4 have everything with all these positive signs in here. So now the coefficients are 3. Here's the 3, it's positive. The -2, it's a -2, not a minus a +2, what you might have been thinking. It's a -2. It's 1n. Here's the 1 right here. 1n. There's 1n. Okay, 1n. And then plus the -4. The constant is -4 right there, -4. And the like terms, they want to know, what are the like terms? Well, the like terms are the -2n and the n. Okay? Okay, in example 1, check your understanding. The directions here: name the coefficients, like terms, and constants, just like we did in the previous slide. I'm going to sit here. I'll wait for a few minutes. But why don't you stop the video, check this out yourself, and try to answer it. And then we'll work them out when you get back. Okay, now you've had time to stop the video and work these out. So let's see if we can do them ourselves here. So in problem A, we have 6 plus 2s and plus 4s. Well, the coefficients. We know the coefficients are what? Those are the terms that multiply the variable. There's 2 variables in here. Or 1 variable, actually, s. S is our variable. And the coefficients multiply the variables, and we're talking about the coefficients. So the coefficients are what? 2 and 4. They're both plus. The like terms, I kind of mentioned that a second ago, are the s's. In this case, it would be the 2s and the 4s. You can add 2s and 4s together and you get 6s. So they're like terms. Okay, so it's 2s and 4s. Those are the like terms. And then the constants, there's only one constant, and the constant is right here. And the definition earlier said a constant is a number that has no variable. So here's the constant, 6. 6 is our constant. Let's look at this. Minus 4x. What is our coefficient? Well, our coefficient is -4. That is a multiplier of the variable. Coefficients multiply the variables. So our coefficient here is -4. The like terms, there's no like terms other than, I guess there's only one term in the whole problem here. So we're going to say it's 4x. I don't know whether they're going to include it or not here. I'll just say the -4x. -4x is the only like term, but I'll leave a little question mark there. Okay? And then the constants, there are no constants. 0 is the only constant, plus 0. So we could say 0 is a constant, or there is no constants. Going down to the next problem, C, we have 9m plus 2r minus 2m and an r. Okay? So, what are the coefficients? The coefficients are the numbers that multiply the variables. Well, 9 is a number multiplying m. 2 is a number multiplying the r. This negative minus 2m here is really going to be written as plus the quantity minus 2m. So that the coefficient there is going to be the -2. It's going to be the coefficient here. And then the coefficient of r is is a given 1. Always, when you see it like this, 1 is understood to be there as a coefficient. So the coefficients are 9, 2, -2, and 1. So 9 plus 2, -2, and 1. The like terms, well, we have 9m and a 2m. So 9m and 2m, or I could say -2m. That's a set of like terms. And another set of like terms is the 2r and the r. Those are like terms. And the constants, there are no constants unless you want to go like we did over here on problem B, and say that there is a constant, because sometimes you have to fill in when you're working problems, you'll find out in the future when we're adding and subtracting polynomials, if there's a zero, if there's a term missing, you're going to have to replace it with a zero. So we can say that there's a zero constant here. Okay, so objective 2, simplifying variable expressions. You simplify a variable expression by replacing it with an equivalent expression that has few terms as possible. Algebra tiles can help you model this process, but we may or may not use them as we move forward. Okay, example 2, we're going to use some tiles to simplify this term. So simplify the term 2x plus 4 plus 3x. Well, we just look at that. We see like terms. We see a constant, some coefficients. So let's look at what that turns out to be here. So we have a 2x. So I'm going to go back and change this to red. So we have the 2x right here. Remember from before, the x's, this is 1x, and this is 1x. And together there are two of them. So it's 2x plus, and the yellow tiles are positive. So plus 1, 2, 3, 4 yellow tiles. Here's the 4 right here. So it was 2x plus 4, and now plus 3. So now we're going to add also 3 more x terms. So when we combine this and simplify means get rid of as many common like terms, do everything you can to get this down to as few terms as possible. And we'll do that by adding the 2x and the 3x together, and you get 1, 2, 3, 4, and 5x, right here, 5x, plus the original 4 that we had all along, plus 4. And that's the answer. That's a simplified version of 2x plus 4 plus 3x. The simplified version is 5x plus 4. Okay, example 2, check your understanding. Like we did before, I'm going to tell you to pause the video and see if you can solve this on your own as you're looking at it. And then when we come back, we'll address it together. But the directions say, use tiles to simplify. 3a plus 2 plus 4a minus 1. Okay, so why don't we go ahead and do that? Stop the video and see if you can make it. You've got the answer right in front of you, but take a look at it and see if you can figure it out without looking at the answer on the bottom of the slide. Oh, and I'll wait. Okay, now that you've paused the video and we're ready, we can move on and do this together. What do we have? We start off with 3a. Here's 3 a's. Could have been x's. They're a's this time. Doesn't matter what you call them. It could be q's, whatever. 3 a's plus 2 constants that are positive. This is 2 positive. So we have 1, 2 positive constants. Then we have plus 4a, which is 1, 2, 3, 4 more a's. And then we're going to take away right here, we're going to add a negative constant. And that's what we did. That's the negative. Remember, the reds are negative, the yellows are positive. Okay, as it says over here in the legend, the red is a negative 1, the yellow is a positive 1 right here, and the green is a 1a, a positive 1a. So when we put these together, we're going to have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, and 7 a's. And then we're going to have the 2 positive constants, so plus 2, and a negative 1, the minus 1. And when we make a zero pair out of these, remember zero pairs from the other chapter, a zero pair, we made a plus and a negative, create a 0. That's a zero-sum pair. What are we left over with? We're left with this right here, this one tile right here. So we have 7. Oh, I'm sorry. It says X down here. It should have said 7a right here. And plus 1. So that creates, remember the zero pair? We had this right here. We're talking about the zero pair right there. Okay, so now we have an example combining like terms. It says simplify 5y plus y. So what do you think that's going to be? You know, we have 2 like terms here. It says add them, basically, right? 5 y's plus 1 y. It's like 5 apples plus another apple, 6 apples, right? But we're going to use the distributive property in here. We're going to take a look at it with the distributive property. And maybe even the identity property of multiplication. Excuse me. So 5y plus y, as you see the terms right here, they're kind of colored coded here. We go into the distributive property. Right here is the distributive property. We have the y. We take the y out and put it outside the parentheses right here. Okay, the y is on the outside, and we have a 5 plus 1. 5 plus 1 on the inside. So now if you add those together, you're going to get this 6y. You're going to 6. So if I write it out, you're going to get 5 plus 1 is 6 times y. And when you do that, now you can get rid of the parentheses, and you're going to have 6y as a result. Okay, example 3, check your understanding. As before, pause the video, look at these. We're going to do the same thing we just did in the last slide. Why don't you go ahead and try it on your own, and I'll wait. Okay, now that you've taken the time to stop the slide and work these out on your own, let's do them together. First thing we're going to do here is we're going to look at A, and we have a 3b and a minus b. Okay, so we're going to use the distributive. Right now, we don't have to move anything anywhere. We can just use the distributive property, and I'll take the y out first, the b out first. So how am I going to take that out? Well, and as a matter of fact, I should do this. I'm going to say first, let's get rid of this negative sign right here, make it a positive. So we have 3b plus the quantity minus b. Okay? And don't forget that the coefficient of b is 1. So now we're going to rewrite this. I'm going to write it as I'm going to take the b out. I'm not going to take the negative sign out. I'm just the b, because there's not a negative sign on this, a minus sign on this one, on this b over here. There's none on that side, so you can't take out the negative. So we're going to take out the b. So we have b times the quantity. The coefficient of the first b is 3. And then it's plus what? We're adding a negative. The b's gone, so all that's left is the 1. Remember I told you the coefficient is 1. You can't get rid of this term. There has to be something. When you take away, there's a 1 remaining. So, and it's negative. Plus a negative. So it's minus 1. Okay? So now we're going to do what this says. We're going to b times 3 minus 1 is 2. And b times the quantity 2 is equal to 2b. There's that one. Let's do the next one. In this case, we could take a negative out if we want to, or we could leave the negative in. We could play it either way. It's not going to hurt us. In fact, let's try it. Let's take the negative out. I haven't thought of doing it this way, but let's try it. So we're going to take out, we can take out the negative m if we want to. So let's take out a negative m to break this up a little bit. And now that we've done that, the negative sign is gone from here, and this plus a negative 9m. Okay, so now those negatives are gone because I took the negative away. I made these both positives. So now it's m times 4 plus 9. Okay, so now we can say minus m is equal times the quantity. 4 plus 9 is 13. And then we put this back together. The negative comes with us, so it's going to be negative 13m. And if you look at it, minus 4 and minus 9 is 13. So, and negative, we took the negative sign out. I could have left the negatives in here and added them in here and inside the parentheses and had a positive m outside. We'd have ended up with the same result. Negative 13m. C, p plus 6p minus 4p. Oh, can we use the distributive property on 3 terms? Well, we've seen this before on some previous slides and other sections. And the answer is yes. They all have a p in the term. We can take p out of every one of these terms, and I'm going to do it right this second. P times the quantity. There's a 1. The coefficient is a given 1 when there's no number in front of the variable. 1 plus 6 plus 6. This is minus. Okay, but remember we're going to change it to a plus so that you can get it straight and not have problems. So it's plus a negative 4 p. So we're going to say now the coefficient we're going to use in here, because we've taken the p out, is negative 4. And now look at that. We have a 1 plus 6 minus 4. So again, I'll write the p times the quantity 1 plus 6 is 7, minus 4 is 3. And the final answer then is 3p. Okay? Okay, example 4, using deductive reasoning. What we're going to look at this problem here is to simplify 4g plus 3 times the quantity 3 plus g. Well, so you've got like terms, and the like term is this 4g, and there's a g inside this parenthesis, so it's floating around, so to speak, inside here, and we have to do something with it so that we can put them together. You can't put this g with the 4g at this point because it has this times 3 along with it, okay? You have to undo that or do it, whatever you want to call it. And it says justify each step. And the reason why they're saying deductive reasoning here is because deductive reasoning says when you're to solve a problem, if you're following specific rules and properties to get from one step to the next, you're using deductive reasoning. You're not coming up with a conclusion first and then going back trying to make your thoughts fit your conclusion or your conjecture. So at this point, we're using deductive reasoning. So what's the first thing we have to do? Deductively, we have to get this 3 right here involved back with the 3 and the plus g. And the way we do that is we're going to multiply using the distributive property. We're going to multiply these terms out to get rid of the parentheses. Okay, so when we do that, we're going to get 4g from here, 4g right there, and then we're going to get 3 times 3 is 9, there's a plus 9 there, and 3 times g here is 3g right here. 4g plus 9 plus 3g. And we did that by using the distributive property. We talked about multiplying this term out to eliminate the parentheses. Okay? Then once you've done that, now we can use the commutative property to move the numbers around. And what we did is we moved the 4g next to, we moved the 3g next to the 4g by swapping the 3g, and we swapped the 3g and the 9 so that we could get them and change the order. We're using the commutative property of addition. And then now we have the distributive property working in reverse. We have this g is multiplied by 4 in one of these terms and 3 in the other term. Okay, so we can factor this g factor in here. We can factor it out. And we're going to factor it out by pulling the g out with the parentheses as we do for distributive property. So we end up with 4 plus 3 times g, because we had the 4g plus 3g. When you take the g's out and move it outside, you've got the 4 and the 3 left. The 4 plus 3 is left. So using the distributive property again to combine the like terms, so now we end up, there's a step kind of missing here. What we need here is we're going to have the 7g. We didn't show us, well, I guess we do, but we have to say add. Normally we would say add down here first. So we have to add the 4 and the 3 and get a 7, and you get the 7g plus the 9. So the answer now is 7g plus 9. So example 4, under check your understanding, directions, simplify each expression, justify your steps. Okay, well, like before, I'll sit here and I'll wait. You go ahead and stop the video and take your time. See if you can solve this on your own. And then when you come back, we'll complete it together. Okay, I'll wait. Okay, now that you've taken the time to do this and we're back together, let's work on problem A. So what do we have? We have a 6y plus a 4m, and we have minus 7y plus m. So first of all, if we were just going to rewrite it, as we talked about before, we're going to move around the way we write this term. I'll just say we have 6y plus 4m plus the quantity negative 7y plus m. And with that m, we know that the coefficient is 1. Okay? So they want us to figure this out. So what are we going to do? We literally, the y term, it's separate. The m terms are separate. All we have to do is combine them. And we'll be combining them using what? In this case, there's no multiplication to be done. They're not asking us to do any multiplication. They just want us to combine the terms and simplify. And we only have addition. So we're going to use, we can move these around a little bit so that we can add them conveniently. And we're going to use the commutative property of addition to move them around. So to do that, we're going to move the negative 7y over here with the 6y and the positive 4m with the m. So we're going to have 6y. And then plus, I'll say plus, a negative 7y. And then I'm also going to move, we talked about moving the 4m over here. So now I'm going to say plus 4m plus m. So that's commutative. That's the commutative property of addition. Commutative property of addition. So now we can combine these. So this is simplifying is what this really is at this point. So we're going to 6y minus 7y ends up being what? A negative y. Could be, I'll start, in fact, I'll do this. It's negative, go right here. It's negative 1y. Just so you see that coefficient there. It's always there. And then we're going to add the m's together. So we have 4m plus an m. So that's going to be 5m. Okay? So we also could have, at this point, looked at this a little differently. We could have taken the 6 and the 7. We could have taken this down here. We could have said 6y plus the quantity negative 7y is the same as saying, we can take the y out. We can say y times 6 minus 7. And then you'd have y times 6 minus 7 would be negative 1. So now you have negative 1y. And you could do the same thing with the 4. Bring it down. Do the same thing. We have 4m plus m. We can take out the m. M times the quantity 4 plus 1m plus 1. This equals 5. So now we have m times the quantity 5. And we have 5m. So the answer then would be negative y plus 5m. You get the same answer. And I used distributive property one time, and one I just did this in my head, but I think maybe they wanted the distributive property. So let's do B. B says, let's do 4x plus 3 minus 2 times, so we have to redo this in the distributive properties because we need to get the terms separated. You can't have this 5 joined here with the x. You have to separate those to have separate individual terms to simplify it. Otherwise, you can never simplify this. So in order to do that, we're going to take, first off, we're going to go ahead and say 4x plus 3, and it's minus 2 times what's in here. So it's minus 2 times 5, so it's minus 10, and it's minus 2 times x, minus 2x. That minus 2 goes with both of those terms. If these were negative in here, or any one of these were negative inside, that would have changed accordingly, with a negative or positive out here. So now that we have that, we have 4x plus 3 minus 10 minus 2x. So here's the plus 3 and the minus 2x. I should have moved this. There you go again, jumping ahead of the game here. I should have moved them right away. So we have the 4x. Let's get the 2 minus, or the negative 2x. We'll bring it over here using the commutative property of addition. So negative 2x. And then the 3 can go with the 10. It's already with the 10 then, but it'll be plus 3 minus 10. So now these can go together. We can either add them directly or use the distributive property. Let's use the distributive property. We're going to take the x out. X times 4 minus 2 plus Well, all we can do here is just add these together. There's no variable term. So now it's just 3 minus 10, so we're negative 7. 3 plus the quantity, negative 7. Okay? And so now we can add these together in here inside the parentheses, and we'll get x times 2 and minus 7. Okay? And now we can write this without the parentheses, and it'll be 2x minus 7. Okay?